Welcome back. The objective of this video is to look at how we can calculate the other variables involved in the annuity formula other than the present value and the annuity amount. Okay, so in this particular question we'll be actually looking at how many annuity payment do we need. Okay, so the situation is that we have some amount of annuity payment where each of them is 30, and we know that its present value is $200, and we want to work out how many annuity payment do we actually need. Okay, so for this example I'm going to be going through it both using the equation method as well as the interest rate method. So the first thing we'll do is we'll look at the equation. We know the equation for present value of an annuity is P equal A bracket 1 minus 1 plus R to the minus N over R. We put in the information we do know, which is P is 200, A is 30, and the rate is 4%. Okay, so we simply put in all the necessary values and we're just going to rearrange and solve for N. So the first thing we do is we time both sides by 0.04 to get rid of that fraction on the right hand side. Okay, so here's just what it looks like. Then we're just going to simplify it a little bit further and divide both sides by 30, and we get that 8 on 30 equal 1 minus 1.04 to the minus N. Then we're just going to swap over the 1.04 to the minus N and the 8 on 30, and then we have 1 minus 8 on 30, which is 11 on 15. So now we're at the point we have 1.04 to the minus N equals 11 on 15, and here is where we're going to use our solve this using logs. Okay, since we have to the power of N. Okay, so next thing we're going to do is we're going to log both sides. We know that from our log rule that if it's to the power we can take it down to the outside. Okay, so we're just simply going to do this as shown. Then we're going to divide both sides by this log 1.04. So now we have minus N equal log 11 on 15 over log 1.04. This is just a number. Okay, so we put that into our calculator and we work out this is minus 7.908. Okay, now since both sides is minus, we can work out that N will be 7.908. Alright, so it means that we need to have 7.908 annuity payments to get a present value of $200. Alright, so now we'll do this using the table method, and one thing I will be introducing is the idea of linear interpolation, which is we're going to approximate to a certain degree of accuracy and then we're just going to use a gradient method to solve for the answer. Okay, so here we're going to say P equal A bracket, find P given A, I, and N. You could have done it the other way around. A equals P bracket A slash P, I, and N. It doesn't really matter, you get the same answer either way. Okay, so here we know our P is 200, we know our A is 30, so we rearrange. We know that we're looking for a find P given A, I, and N to equal 6.666. Okay, we know our interest rate is 4%. So now all we do is now go to the back of our interest rate table, look up the page for 4% interest rate, and we look at our find P given A column, and we look for the N that is closest to 6.666. Okay, so if we do that, we find the two closest one is when N equals 7, we get 6.0021, and when N equals 8, which is 6.7327. So here is too low and here is too high. So we know that our N has to be somewhere in between these two. So this is when we use the idea of linear interpolation, and all it is just equating two gradients. Okay, and you should have done this in SCAD last year. Otherwise, here's how we do it. Okay, so we go, essentially it's just your rise over run. So we go 7 minus 8 because the 7 is for this term. Okay, we minus that term and we get the equivalent coordinate or value. So 6.0021 minus 6.7327, and this has to equal the value we're looking for. So this is the time period minus 8. You can do 7, doesn't matter, divided by the value we know for that n, which was 6.666 minus 6.7327. So the thing you always need to notice is whoever you're minusing who, it must be the corresponding value. So if you're going to go 8 minus 7, then this bottom has to be 6.7327 minus 6.0021. Okay, once you have set it up like that, it's very easy to solve. The left hand side becomes 1.3687. We times it by this value. You can work out what this is if you want. Okay, so I just simply move that to that side and get that. This is what it becomes. I solve for it here, so this whole thing up here becomes minus 0.0904 equal x minus 8. So we plus the 8 on to the other side like this, and we get that our x, which is the number of year that we've been looking for, to be 7.909, which is very close to the 7.908 that we calculated using the equation method. So you can see that using either the table method or the equation method, you will get the same answer regardlessly. Thank you.